Right. Good evening, everyone. So I will start the class. Right. So today I will start the new unit, unit number 11, chemical kinetics. So first I will tell you about this unit, how many questions are given in the exam and what is the structure of the unit. Right. So here in the chemical kinetics, this is an important unit in grade 13, right? Because we know the unit number 11. Unit number 11 is chemical kinetics. Unit number 11, chemical kinetics. And unit number 12, unit number 12 is equilibrium. Equilibrium. And unit number 13, it is electrochemistry. Electrochemistry. And unit number 14, industrial chemistry. Industrial chemistry and environmental pollution. Environmental pollution. Right. So this unit, the chemical kinetics unit, otherwise the knowledge behind the chemical kinetics unit required the equilibrium part and mainly industrial chemistry and environment part, and some few theories are required in the electrochemistry part, right? So therefore, these two units are related together, right? Without chemical kinetics, it is difficult to study the equilibrium. Without these two units, difficult to study the electrochemistry, right? And the final unit, to study the final unit, the theory behind these three units are required, right? Therefore, these 4 units are very important because in the syllabus, these 4 units are allocated to the grade 13, right? Grade 13. These 4 units are allocated to the grade 13, right? That means from unit number 1 to unit number 10, grade 12, and the last 4 unit, grade 13, right? Therefore, that means the amount of unit number 12, we can equalize to the amount of unit number 4, right? And in the exam, uh, here I will write down the number of MCQs. So generally in chemical kinetics, 3 MCQs are given, and equilibrium about 7 to 8 MCQ. I will write down as 8 MCQ, and electrochemistry about 2 MCQ, and industrial and environment about 4 to 5 MCQ. Then altogether MCQ, this is only MCQ, right? 11, 15, sorry, 11, 13, 13 plus 5, 13 plus 5 means 18. So these 4 units, 18 MCQs are given. About 18, it can be 20, sometimes it can be 17, right? And when consider the chemical kinetics, last few years, we know the first structure, general chemistry, second structure, inorganic, third structure, physical, fourth structure, organic, right? So in the last few years, the structured question was given by the chemical kinetics unit, right? Last few years, some few years the equilibrium question, the question is given in the equilibrium. Previous question is given in the chemical kinetics, right? So therefore, assume the if a structured question is given, we can get 5 marks, right? So 5 marks. So approximately about 7 to 8 marks can be scored from this chemical kinetics unit, right? So therefore, this is very important unit. Chemical kinetics is important unit. To study this one, the knowledge of this one is required, right? And to study the other future units, 13 and 14, the theory behind chemical kinetics is important, right? So then next one. So in this lesson, there are mathematics part. That means there are calculation part and some theory part. And to study this unit, we required the knowledge behind fourth unit, gas unit, knowledge behind mainly the energetics and chemical calculation. 3, 4, 5. 3, 4, 5 are required, right? So the mainly the exam result depends on these 4 units, right? So because the lot of questions, so we can say approximately 50 mark, right? Because these are grade 13. So 50 or more than 50 in the paper, both MCQ and second paper, 50 or more than 50 can be scored by using these 4 units, right? By using these 4 units. From 1 to 10 units, we can score about approximately 50, and here 50 or more than 50, because a lot of questions are given by these 4 units. Right. So then today I will start the chemical kinetics part. Right. Then I will start the lesson. Write down. Write down the topic, unit 11. Unit 11, chemical kinetics. Chemical kinetics. Chemical kinetics. Unit 11, chemical kinetics. Chemical kinetics. Right. එතකොට ඔයගොල්ලෝ මේ යුනිට් එක හොඳට ස්ටඩි කරන්න ඕනේ. මොකද මේ යුනිට් එකෙන් ඊළඟට තියෙන 12, 13, 14 මිනිට්ස් තේරෙනවද තේරෙන්නේ නැද්ද කියන එක ඇත්තටම මේකේ ඩිපෙන්ඩ් වෙනවා. හරිද? ඊට පස්සේ එක්සෑම් එකේ සාමාන්‍යයෙන් මේ යුනිට් එකෙන් ලකුණු මං කියවා approximately 8 වගේ අපිට ස්කෝර් කරන්න පුළුවන්. සහ මේක අර ගොඩක් යුනිට් වලට රිලේටඩ්. එහෙනම් මේ ගොඩක් ඉම්පෝර්ටන්ට් යුනිට් එකක්. හරිද? Right. So chemical kinetics. So here I will say the background of this unit. So here mainly we discuss the rate of the reaction. So mainly here we discuss about the reaction, right? The main topic is the rate of the reaction, right? So there is a definition, the rate of the reaction. I will tell it later. So now here simply we can say what is the rate of reaction, amount of product produced per unit time, right? In a chemical reaction, amount of product produced per unit time within 1 second or 1 minute, we can say the rate of reaction, right? So the rate of reaction is very important factor in day-to-day life, because in some situation we need to decrease the rate of reaction, and some situation we need to increase the rate of reaction, right? That means we should be able to control the rate of the reaction. So mainly consider the industries. So in the industries, some products we produce, right? So to get the higher profit, we should be able to produce more product within 1 day or 1 month, right? Therefore, the knowledge behind the rate of reaction is important in that situation, right? And in the medicine, industries, right? So likewise, the rate of reaction, the theory of the rate of reaction is more important in those kind of situation, right? So here the first topic, before discussing the rate of reaction, the first topic is requirements that should be satisfied to produce product, right? So first topic is requirements. First topic, requirements that should be satisfied to produce the product. Right. requirements that should be satisfied to produce the product. That's the first topic, right? In this lesson, the first topic is requirement that should be satisfied to produce the product. Okay, write down this topic, the first topic, requirements that should be satisfied to produce the product. To produce the product. Requirements that should be satisfied to produce the product. Right? ඒ කියන්නේ දැන් රියැක්ෂන් එකක් වෙද්දී ප්‍රොඩක්ට් එක ප්‍රොඩියුස් වෙන්න රියැක්ටන්ට් මොලිකියුල් වලට තියෙන්න ඕන රික්වයර්මන්ට්ස් තුනක් තියෙනවා. ඒ රික්වයර්මන්ට්ස් තුනම සැටිස්ෆයි වුණොත් විතරයි ප්‍රොඩක්ට් එකක් හැදෙන්නේ. ඒතර ඒ රික්වයර්මන්ට් තුනෙන් එකක් හරි නැත්නම් ප්‍රොඩක්ට් එක ප්‍රොඩියුස් වෙන්නේ නැහැ. Right? So then I will discuss what are those requirements, right? Okay, listen carefully. All the topics are related together, right? That means the knowledge behind this topic is required the next topic, second topic, and the knowledge behind first and second required the third, like this way. The theory of this chemical kinetics combined together each topic, right? Okay, so what is the first requirement? The first requirement is reactant molecule should collide. Reactant molecules should collide. Should collide. Right? That means now I will consider a simple example. The sodium and water react together producing sodium hydroxide and H2. Right? To produce sodium hydroxide and H2 by reacting sodium and water, what is the first requirement? The sodium should collide with water. So sodium එක තැනක ඉන්නවා, water තව තැනක ඉන්නවා. කවදාකවත් sodium hydroxide H2 කියන එක හැදෙන්නේ නැහැ නේ, right? A simple thing. The first thing is the reactant molecule should collide. That's the first requirement, right? The simple thing. The second requirement, it is important. Reactant molecule should collide in proper orientation. Reactant molecule should collide in proper orientation. Proper orientation. ඒ කියන්නේ නිකන් collide වුණාට හරියන්නේත් නැහැ. They should collide in proper orientation. Proper orientation, right? So I will consider an example to explain this proper orientation. So example is, now consider the reaction between NO and Cl2, right? Nitrogen monoxide react with chlorine producing NOCl and chlorine, right? So here I will draw the structure of NO, nitrogen double bond oxygen, and chlorine like this. Here I will not indicate the lone pairs. And the product NOCl structure is this one, like this, right? So now, here when consider this reaction, we can write down main two collision, right? Mainly two collision. First collision, symbol A. Here first collision, symbol A. This is NO molecule, chlorine molecule, and B. Here right, what is the first collision? First collision is like this. That means the NO molecule, sorry, the oxygen atom of NO molecule, the oxygen atom of NO molecule can collide with chlorine atom. That's the first collision, right? Then other collision, the nitrogen atom of NO molecule can collide with chlorine atom. These are the main two collision. Oxygen atom of NO collide with chlorine, otherwise nitrogen atom of NO collide with chlorine. When we consider the product, here we can see the product, NOCl product. Here there is a nitrogen chlorine bond, right? To produce the nitrogen chlorine bond, to produce this nitrogen chlorine bond, the nitrogen should collide with chlorine, not oxygen with collide with chlorine. So මේ NCl bond එක produce වෙන්න oxygen chlorine එක collide වුණාට වැඩක් තියනවද? වැඩක් නැහැ. හරිද? එතකොට මොකද්ද වෙන්නේ? This will not form product. So therefore this is improper collision. මේ collision එකෙන් වැඩක් නැහැ. nitrogen chlorine එක collide වුණාට NCl bond එක produce වෙන්න බැරි හින්දා මෙතනින් product එකක් හැදෙන්නේ නැහැ. හරිද? And this is the proper collision. Now nitrogen collide with chlorine. Therefore this nitrogen can form a covalent bond with chlorine, producing NOCl, and the chlorine bond is break, producing chlorine atom. So this is known as a proper collision. ඒ කියන්නේ product එකේ තියෙන bonds හැදෙන්න පුළුවන් විදිහට atoms collide වෙන්න ඕනේ. ඒක තමයි කියන්නේ the reactant molecule should collide in proper orientation කියන්නේ අන්නේ requirement එකට. Right? So then what is the third requirement? Third requirement is reactant molecules should have activation energy. So the symbol of activation energy is capital E and simple A. EA meaning is activation energy. Reactor molecules should have at least, right? At least activation energy. I will learn at least activation energy, right? Then there is a question, what is activation energy, right? Activation energy means when reaction proceed, right? When reactant converts to product, directly reactant will not convert to the product. Can reaction එක process වෙද්දී එකපාරම reactant collide වෙලා product එකට convert වෙන්නේ නැහැ. ඒ අතරමැද structures ගොඩාක් හැදෙනවා. හරිද? ඒ අතරමැද structures ගොඩාක් හැදෙනවා. ඊට පස්සේ තමයි finally product එක produce වෙන්නේ. Right? So then the activation energy. So here I will draw this is known as energy profile. මේ ගැන අපි පස්සේ වෙනම discuss කරනවා. Here this is known as a potential energy, and here reaction coordinate. So now consider the reaction like A goes to B. Simply A goes to B. A is a reactant and B is a product. So A කියන එක B ට convert වෙද්දී එකපාරම A කියන එක B ට convert වෙන්නේ නැහැ. මේ අතරමැද තව structures ගොඩාක් හැදිලා තමයි මේ product එකට convert වෙන්නේ. එතකොට අපිට මෙතන අඳින්න පුළුවන් අපි කියනවා මේකට energy profile, otherwise reaction coordination diagram. Now consider this reaction is endothermic. This is endothermic reaction. Endothermic means energy of capital B is higher than A, right? So then we can draw this kind of diagram like this. Here this is the energy of capital A, this is the energy of capital B. The energy difference between capital A and capital B, this is known as enthalpy change, delta H, right? තොර මෙතන මේ curve එකෙන් පෙන්නන්නේ දැන් A කියන එක gradually change වෙලා තමයි B ට convert වෙන්නේ. තොර ඒ අතරමැද හැදෙන structures තියෙනවා ඒවා අපි පස්සේ අඳිමු. ඒතොර ඒ අතරමැද හැදෙන structural energy variation එක මෙන්න මෙහෙම තමයි තියෙන්නේ. එතකොට මෙන්න මේ A to B කියන conversion එක මැදදී හැදෙනවා higher energy එකක් තියෙන state එකක් structure එකක් මෙන්න මෙතන හැදෙනවා special structure එකක්. This is known as activated complex. Short symbol is AC, otherwise there is another name, transition state. state, TS, right? Transition state. So therefore, when reaction proceed, we can say the reactant does not convert to product directly. First, reactant converted to activated complex, then activated complex turns to the product, right? So then the energy difference between this reactant, energy difference between this reactant and activated complex is known as activation energy. So reaction එක process වෙද්දී එකපාරම reactant product එකට convert වෙන්නේ නැහැ. Reactant turns to activated complex, then activated complex turns to the product. So the energy difference between reactant and activated complex known as activation energy. So the third requirement එක තමයි the reactant molecule should have at least activation energy. So මේක energy value එකක් අපි හිතමු නිකන් like 10 කියලා හිතන්න. The activation energy of this reaction is 10 kilojoules per mole. එතකොට මේ medium එකේ තියෙන 10 otherwise more than 10 10 හරි ඊට වඩා වැඩි energy එකක් හරි තියෙන capital A molecule වලට විතරයි activated complex එක හදන්න පුළුවන්. activated complex එක හැදුනොත් තමයි product එකට convert වෙන්නේ. activated complex එක හැදුන්නේ නැත්නම් මේ මගට ඇවිල්ලා නවතිනවා. ඒකෝර මෙතෙන් යන්න බෑ හරිද? මෙතන simply හිතන්න කන්ද මුදුනට යන්න පුළුවන් නම් පල්ලෙහාට එන්න පුළුවන්. ඒතකොට කන්ද මුදුනට යන්න තරම් එනර්ජි එකක් නැත්නම් කන්ද මැදින් නවතින්න වෙනවා. හරිද? අන්න ඒ වගේ තමයි මේ reactant molecule වලට මෙන්න මෙතෙන්ම යන්න තරම් එනර්ජි එකක් නැත්නම් ඒක මගින් නවතිනවා. ඒතකොට මේ product එකට convert වෙන්නේ නැහැ. මෙතෙන්ද යන්න ඕන එනර්ජි එක කියන්නේ 10 හරි more than 10 හරි එනර්ජි එකක් තිබ්බොත් තමයි the reactant turns to the activated complex, then activated complex turns to the product, right? So that is the third requirement. So ඔන්න ඔය කිව්ව requirements තුනම තියෙන කට්ටිය විතරයි product එකට convert වෙන්නේ, right? That means reactant molecule should collide. First requirement, reactant molecule should collide. Second requirement, they should collide in proper orientation, otherwise correct geometry, right? Second requirement. And third requirement, when reaction proceed, reactant does not convert to the product directly. First, reactant converts to the activated complex, then that activated complex turns to the product, right? Activated complex turns to the product. Therefore, the reactant molecule should have at least activation energy. Then what is activation energy? The energy difference between reactant and activated complex. මේ energy profile එක ගැන මෙතෙන්දී in detail discuss කරන්න අමාරුයි, right? මොකද මේකට අපිට previous knowledge එක ඕන වෙනවා. හරිද? So therefore about this energy profile I will discuss later. So now just understand these are the three requirements that should be satisfied to produce the product. Right, now we can write down the note. Okay, so this is a topic requirement that should be satisfied to produce product. Okay, write down under that. To produce the products from reactant, to produce the products from reactant, to produce the products from reactants, following three requirements should be satisfied. Following three requirements should be satisfied. Following three requirements should be satisfied. Write down first one. Write down first requirement. Reactant molecule should collide. Reactant molecule should collide with each other. reactant molecules should collide with each other, should collide with each other. Reactant molecules should collide with each other, should collide with each other. That's the first requirement. Then write down second requirement. Reactant molecules should collide in proper orientation. Reactant molecules should collide. Reactant molecules should collide in proper orientation, should collide in proper orientation. Reactant molecules should collide in proper orientation. Write down example. Write down this one, example. Then write down this part. Example, NO plus Cl2, NOCl plus Cl. Then draw the Lewis structure inside the bracket. NO plus Cl2, NOCl plus chlorine. Then draw the structures of the Lewis structures of the reactant and product. Only this part, right? Right, then write down NO and Cl2 molecules. NO and Cl2 molecules can collide two different ways. NO and Cl2 molecules can collide in two different ways. Can collide in two different ways. Right. Write down simple A. Simple A. Simple A. Then draw this one. Simple A. Then draw this one. Simple A. Draw this one. The oxygen atom of NO molecule collide with chlorine. It is improper collision because the NCl bond cannot be formed. Right. Then write down the oxygen atom of NO molecule. The oxygen atom of NO molecule. The oxygen atom of NO molecule can collide with the oxygen atom of NO molecule can collide with chlorine atom of Cl2 molecule can collide with chlorine atom of Cl2 molecule. 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 But chlorine atom of Cl2 molecule. But the NCl bond cannot be formed. But the NCl bond of NOCl, but the NCl, nitrogen chlorine bond of NOCl cannot be formed. NOCl cannot be formed. Cannot be formed. Therefore, they will not, they will not, they will not they will not converge to the product. They will not converge to the product. They will not converge to the product. Then simple B, write down simple B. Write down this one. Simple B. Simple B is the nitrogen atom of NO collide with chlorine atom of Cl2. Simple B. Nitrogen atom of NO collide with chlorine atom of Cl2. Right. Then write down nitrogen atom of NO. Nitrogen atom of NO. Nitrogen atom of NO can collide with chlorine atom of Cl2 molecule. 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 Then the NCl bond can be formed. Then the NCl bond can be formed. Then the NCl bond can be formed. The NCl bond can be formed. Therefore, they converge to the product. 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 So, therefore, they converge to the product. So, this is the proper collision. Therefore, this is the proper collision. Therefore, this is the proper collision. Therefore, this is the proper collision. This is a proper collision. Right. Then write down third requirement. Third requirement. Reactant molecule should have at least activation energy EA. Third requirement. Reactant molecule should have at least activation energy. Reactant molecule should have at least activation energy within bracket EA. EA. At least activation energy within bracket EA. EA. Right. Then write down under that. Write down under that. When reaction proceed, when a reaction proceed, when a reaction proceed, when a reaction proceed, reactants do not convert, reactants do not convert, reactants do not convert, reactants do not convert to the product directly. Reactants do not convert to the product directly. To the product directly. To the product directly. First, reactants are converted to the higher energy state. First, reactants are converted to the higher energy state. Reactants are converted to the higher energy state known as higher energy state known as reactants are converted to the higher energy state known as activated complex slash transition state. 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 Then this activated complex is converted to the product. Then this activated complex, then this activated complex is converted to the product. Then this activated complex is converted to the product. This activated complex is converted to the product. Converted to the product. Converted to the product. Then write down separately, separate sentence. The energy difference between the energy difference between the energy difference between the energy difference between reactant and activated complex, reactant and activated complex, reactant and activated complex, reactant and activated complex is known as activation energy. The energy difference between reactant and activated complex is known as activation energy. Activation energy. To produce the product, 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 reactant molecules should have activation energy. Reactant molecules should have activation energy O more than activation energy. Should have activation energy. O more than activation energy. Right. Then write down as example. Let's write down this one example. This is a reaction. After that, draw this diagram. First write down this one, then after that draw this diagram. Right. So therefore, first reactant converts to activated complex, then activated complex converts to the product. So to form the product, reactant molecule should have at least this energy, activation energy. Right. So then the final conclusion, to form the product, reaction should collide. They should collide in proper orientation, and the reactant molecule should have at least activation energy. Right. So therefore, all these three requirements should be satisfied to form the product. Right. Okay. So after this one, write down. After this one, write down. To form the product, to form the product, to form the products, reactant molecules should satisfied to form the products. Reactant molecules should satisfy. Reactant molecules should satisfied all above three requirements. Reactant molecules should be satisfied all above three requirements. All above three requirements. All above three requirements. All above three requirements. Right. So then I will explain this one further by considering the Maxwell-Boltzmann distribution curve. The Maxwell-Boltzmann distribution curve, we can study this theory in gaseous state of matter, unit number 4. So in this Maxwell-Boltzmann distribution curve, the y-axis we can name as a molecular fraction. Molecular fraction. And x-axis I will label as a kinetic energy. Molecular fraction and kinetic energy. Sometimes we can label this as speed as well. Here I will label this is as a kinetic energy. I will consider kinetic energy and molecular fraction, right? So then the Maxwell-Boltzmann distribution curve like this kind of graph, right? And here, when we consider the chemical reaction, we know there is an energy, specific energy barrier. It is known as energy barrier. It is known as a activation energy, right? So now the energy, kinetic energy of reactant molecule vary like this. So now here I will mark the activation energy. Now consider the activation energy here, right? This is the activation energy, right? So now we can mark this region. In this region, what is this region? I will label this region as a region B, region B, region B, and this is region A, right? What is region B? In region B, the molecule contained in this region B have activation energy. And molecule contained in region A don't have activation energy. तොර මේ පැත්තේ තියෙන කට්ටියට මේකෙන් එහාට තියෙන මොලිකියුල් ටිකට ඇක්ටිවේෂන් එනර්ජි එක නැහැ. මෙතනින් එහා කට්ටියට තමයි ඇක්ටිවේෂන් එනර්ජි එක තියෙන්නේ. Right? And this region A, මේ A කියන region එකේ there are two type of molecules. And region B there are two type of molecules. Region A two type of molecule, region B two type of molecule. What are they? In region B there are molecule, right? They collide in proper orientation but don't have activation energy. Properly collide වෙනවා. හැබැයි activation එක නැහැ. මේ පැත්තේ කාටවත් නැහැ. හරිද? එතකොට මේ පැත්තේ වර්ග දෙකක් තියෙනවා මොකද්ද? They collide properly but don't have activation energy. First one. And other one, they collide improperly and don't have activation energy. මේ region එකේ properly collide වෙනවා, activation energy එක නැහැ කොහොමත්. Improperly collide වෙනවා, activation energy එක නැහැ. වර්ග දෙකම තියෙනවා. එතකොට මේගොල්ලොන්ට පුළුවන් product හදන්න. මේ region එකේ තියෙන කාටවත් product එක හදන්න බෑ. මොකද දැනටම එක requirement එකක් නැහැ. හරිද? එතකොට මේ region එකේදී තියෙන molecule properly collide වුණාත් වැඩක් නැහැ. එතකොට properly collide වෙන කට්ටිය හදන්නෙත් නැහැ. improper collide වෙන කට්ටිය හදන්නෙත් නැත. And here in this region we can't say all the molecule in the region B produce product. මේ region එකේ තියෙන ඔක්කොලාම product එක හදන්නෙත් නැත. That means in this region there are two type of molecule. What are they? Molecule collide in improper collision having activation energy. Activation energy එක තියෙනවා but they collide in improper collision. Properly collide වෙන්නේ නැහැ. හරි? ඒතර එක requirement එකක් නැහැ කියන්නේ product එකට convert වෙන්න බෑ. And here other one molecule collide in properly having activation energy. Properly collide වෙනවා activation energy කියන requirement දෙකම තියෙන molecule උත් මේ region එකේ තියෙනවා. ඒතර අන්න ඒ විදිහට මම කිව්වට second type molecule. The molecule collide in properly having activation energy. අන්න ඒ කට්ටිය විතරයි product එකට convert වෙන්නේ. Right? So therefore I will write down region A, first one, first type molecules collide properly without having activation energy. And second one, molecule collide improperly without having activation energy. And region B, I will put a 3 molecules collide improperly having activation energy. Region B වල තියෙන ඔක්කොටම activation energy එක තියෙනවා. හරිද? Molecules collide properly having activation energy. Right? එතකොට මේ වර්ග හතරෙන් මේගොල්ලොන්ට ප්‍රොඩක්ට් එක හදන්නත් බෑ, මෙයාලට හදන්නත් බෑ, මෙයාලට හදන්නත් බෑ, මෙයාට විතරයි පුළුවන්. Right? fourth type එකට විතරයි පුළුවන්. එතකොට මෙන්න මේ fourth type එකේ collision එකට අපි special නමක් කියනවා effective collision. මෙන්න මේකට අපි කියනවා මොකද්ද? effective collision. effective collision කියන්නේ මේගොල්ලොන්ගෙන් විතරයි ප්‍රයෝජනයක් තියෙන්නේ. මේගොල්ලොන් විතරයි product එකට convert වෙන්නේ. Right? They have activation energy and they collide in proper orientation. Therefore, they can produce product. Therefore, this is known as a effective collision. Right? Therefore, in chemical reaction, only effective collision produce product. Right? එතකොට අපි සාමාන්‍යයෙන් ගත්තහම generally normal chemical reaction එකක් අපි consider කරාම ඒ reaction එකේ තියෙන reactant molecule හැමෝටම මෙන්න මේ requirement එක නෑ. හරිද? ඒ කියන්නේ හැමෝම properly collide වෙලා activation energy කියන මේ requirement දෙකම නෑ. කියන්නේ all the collisions are not effective collision. එතන සාමාන්‍යයෙන් අපි chemical reaction එකක් practically කරාම ඒ reaction එකේ තියෙන reactant ඔක්කොම ටික product එකට convert වෙන්නේ නෑ සාමාන්‍යයෙන්. තේරුණාද? ඒ reaction එකේ තියෙන reactant ඔක්කොම ටික product එකට convert වෙන්නේ නෑ. So, past papers වල එහෙම දීලා තියෙනවා percentage yield, calculate the percentage yield of the product වගේ questions දීලා තියෙනවා. එතකොට එතෙන්දී අපිට දෙනවා මේ ඇත්තටම product එක කොච්චරද හම්බුනේ කියලා අපිට දෙනවා. Right? මොකක් හරි chemical reaction එකක් දීලා මෙන්න මෙච්චර product එකක් හම්බුණා, then calculate percentage yield. so percentage yield කියන්නේ අපි theoretically අපිට calculate කරන්න පුළුවන් මේ reaction එකේ reactant ඔක්කොම product එකට convert වුණොත් කොච්චර product එකක්ද හැදෙන්නේ. ඊට පස්සේ ඇත්තටම කොච්චරද හැදිලා තියෙන කියන එක අපිට දෙනවා. ඒක ප්‍රැක්ටිකල් එක කරාට පස්සේ කොච්චරද ඇත්තටම හැදුනේ කියන. එතකොට ප්‍රැක්ටිකලි ඇත්තටම හැදිච්ච ප්‍රොඩක්ට් එක උඩට දාලා theoretical value එක යට දාලා 100 වලින් multiply කරාම අපිට එනවා percentage yield කියලා. කියන්නේ අපි තුමු percentage yield එක 80% කියලා. That means only 80% of the reactant molecule have this requirement. ඒ reaction එකේ තියෙන reactant molecule වලින් 80%කට විතරයි මෙන්න මේ properly collide and activation energy කියන requirement දෙකම තියෙන්නේ. අන්න ඒ විදිහට සාමාන්‍ය ඕනම reaction එක 100%ම reactant ඔක්කොම product එකට ගොඩක් වෙලාවට convert වෙන්නේ නැත. right. Then write down this note. තොර මතක තියාගන්න activation energy එක තියෙන හැමෝම product එකට convert වෙනවද? නැත. ඇයි? activation එක තිබ්බට properly collide වෙන්නේ නැති කට්ටියක් ඉන්නවා. ඊට පස්සේ properly collide වෙන හැමෝම product එකට convert වෙනවද? No. Right? There are few molecules collide properly but they don't have activation energy. Right. Write down consider Maxwell-Boltzmann distribution curve. Consider Maxwell-Boltzmann distribution curve. Consider Maxwell-Boltzmann distribution curve. Consider Maxwell-Boltzmann distribution curve. Draw this curve. Maxwell-Boltzmann distribution curve. Maxwell-Boltzmann distribution curve. Right, then write down in region A, right, write down in region A, there are two types of molecules. There are two types of molecules. In region A, there are two types of molecules. There are two types of molecules. Write down first one. Molecule collide properly without having activation energy. First one, molecules collide properly without having activation energy. Second one, molecules collide improperly. Molecules collide improperly without having activation energy. Molecules collide improperly without having activation energy. Without having activation energy. Then write down next. Write down next. Region B, there are two types of molecules. 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 And third one, molecules collide improperly having activation energy. Molecules collide improperly having activation energy. Third type, molecules collide improperly having activation energy. Then fourth one, molecules collide properly. Molecules collide properly. Molecules collide properly having activation energy. Having activation energy. Molecules collide properly having activation energy. Having activation energy. Right. Then write down. All the molecules in region B. All the molecules in region B. All the molecules in region B do not convert to the product. All the molecules in region A. All the molecules in region A do not converts to the product. All the molecules in region A do not convert to the product because they all don't have activation energy. Because they all don't have activation energy. Because they all don't have activation energy. Activation energy. Activation energy. Then write down next. In region B, in region B, only the molecules in fourth category. In region B, only the molecules in fourth category. Only the molecules in fourth category. Only the molecules in fourth category. Molecules in fourth category. Only the molecules in fourth category produce products. Only the molecules in fourth category produce product. Only the molecules in fourth category produce product. They are known as effective collision. 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 Right. So therefore, only the effective collision produce product. Right. Then write down next topic. Factors affecting the rate of reaction. Factors affecting the rate of reaction. Rate of reaction. Factors affecting the rate of reaction. Factors affecting the rate of reaction. එතකොට මේකේ තියෙන ගොඩක් important topic එකක් තමයි මේක. සාමාන්‍යයෙන් හැම අවුරුද්දක වගේ මේකෙන් MCQ එකක් අනිවාර්යෙන් MCQ එකක් සාමාන්‍යයෙන් අහනවා. second structured හරි essay part එකේ හරි question එකක් තියෙන්නත් පුළුවන්. හරිද? So here first I will tell the rough idea of the rate. මේ rate of reaction කියන එකට ටිකක් complicated definition එකක් තියෙනවා. මම මෙතෙන්දී ඒක discuss කරන්නේ නැහැ. නිකන් simple idea එක තමයි මොකද්ද? amount of product produced per unit time. දැනට එහෙම ගත්තා නම් හරි. හරිද? එතකොට the amount of product produced per unit time. يعني තප්පරයකදී product එක කොච්චරක්ද හැදෙන්නේ කියන එක decide වෙන factors මොනවද කියන එක තමයි මෙතෙන්දී අපි discuss කරන්නේ. හරිද? හරි. එතකොට first thing we know to form the product, otherwise to convert reactant to product, what are the requirements? They should collide proper orientation. They should collide proper orientation, and they should have activation energy. අර පළවෙනි collide කියන එක දෙවෙනි එකේ තියෙන නිසා ඒක වෙනම specify කරන්න ඕනේ නැහැ කියන්නේ. First requirement should collide. Properly collide කියන එකේ collide කියන වචනේ තියෙනවා. හරිද? ඒ හින්දා අපි මේ දෙක එකට කරලා properly collide කියලා ගන්න පුළුවන්. It is okay, right? Right. Then what is to get the more product in unit time, right? To get the more product in unit time, what we have to do, we have to increase the number of proper collision. For a properly collide window, they should have activation energy, right? So therefore, to produce more product, what we have to do, we have to increase the number of proper collision, or we have to increase the number of molecules having energy greater than activation energy. Right? Do you understand? To get the more product within unit time, what we have to do, we have to increase the number of proper collision. And we have to increase the number of molecules having energy greater than activation energy. ඔය දෙකම හරි. ඔය දෙකෙන් එකක් හරි අපි කරන්න. Then what happen? More products are formed. Then how? Otherwise, what are the factors we can use to control those two? Right? What are the factors we can use to increase the number of proper collisions and otherwise or number of molecules having energy greater than activation energy? Right? So there are mainly 5 factors. What is the first factor? First factor is temperature. By controlling the temperature, we can control the number of proper collision and number of molecules having activation energy. Then second one is a concentration. Otherwise, we can say pressure if gas. Right? If gas is present, we can take a pressure instead of concentration, because in a gas we know the pressure proportional to the concentration. And third one, physical state, physical nature of reactant. Physical nature of reactant. Otherwise, we can say the surface area of solid reactant. Surface area of solid reactant. And fourth one, catalyst. And fifth one, we can say the radiation. මේ radiation කියන එක නම් ටිකක් අර specific reaction ටිකක්, some reaction, only for some reaction, right? මේක වැඩිය ඩිස්කස් කරන්නේ නැහැ. රේඩියේෂන් කියන එක mainly ඇත්තටම 4 factors: temperature, concentration, surface area of solid reactant and catalyst. මේකත් අර සමාන reaction වලට විතරක් apply වෙන එකක්. ඒකත් පොඩ්ඩක් අපි ඩිස්කස් කරමු, right? එතකොට මෙන්න මේ කියන factors පහෙන් අර මම කිව්ව දෙක, number of proper collisions එහෙම නැත්නම් number of molecules having energy greater than activation කියන මේ දෙක අපිට control කරන්න පුළුවන්. දෙකම හරි, දෙකෙන් එකක් හරි control කරන්න පුළුවන්. හරිද? right, එතකොට අපි මේ factors එකින් එක අරන් discuss කරමු. right, write down the topic factors affecting the rate of reaction. Then under that write down simply the rate of reaction can be defined as simply the rate of reaction can be defined as the rate of reaction can be defined as amount of product produce per unit time. Amount of product produced per unit time. Amount of product produced per unit time. Amount of product produced per unit time. Then write down next. To increase the rate of reaction, 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 number of proper collisions, number of proper collisions, O, number of proper collisions, O slash and number of proper collisions, O slash and number of proper collisions, O slash and number of molecules having activation energy, number of molecules having activation energy, number of molecules having activation energy should increase. Number of molecules having activation energy should increase. Should increase. Should increase. Should increase. Should increase. Then write down separately. Write down separately. The rate of reaction. The rate of reaction depends on the following 5 factors. The rate of reaction depends on the following 5 factors. Following 5 factors. Write down. Write down first on temperature. Write down these 5 factors. Temperature, second one concentration, within bracket pressure if gas, Third one, physical nature of reactant, otherwise surface area of solid reactant. Fourth one, catalyst. Fifth one, radiation. Right, then I will discuss each factor separately. Factor separately. Right, first write down temperature. First factor, temperature. Temperature. Right. So to study the temperature effect, we can use this kind of experiment, right? So this is water bath. This is water bath. Inside this water bath, we can place conical flask like this. This is conical flask. And inside this conical flask, into this conical flask, we have to add 3 solutions. Don't draw, listen. So here this conical flask contains 3 solution. What? 1 moles per decimeter, 10 cubic centimeter sulfuric, and 0.01 moles per decimeter, 10 cubic centimeter KMnO4 plus 0.01 moles per decimeter, 25 cubic centimeter sodium oxalate, right? Both these conical flasks, we should add 1 moles per decimeter sulfuric 10, 0.01 KMnO4 10, 0.01 sodium oxalate 10, right? So now these two are conical flasks. Conical flasks. And these are water bath. Water bath. And here, outside here, there is water. This is water. This water contain at 25 Celsius. Water at 25 Celsius. And here water at 60 Celsius. Water at 60 Celsius. Then what's the reaction? The MnO4 minus aqueous react with oxalate ion. Then MnO4 minus reduced to Mn plus 2. Oxalate oxidized to carbon dioxide. This is a reaction, right? So now this MnO4 minus is purple in color. Purple color. Mn plus 2, this is colorless. Right? Therefore, if this reaction complete, we can observe purple color decolorize. Purple color turns to colorless. Right? Then what we have to do? We have to construct this setup. Then we have to observe what happened to this one and this one. Right? So then what is observation? We can see the purple color decolorize faster in the solution contained in 60 Celsius. මෙන්න මේකේ අපිට පේනවා purple color එක ඉක්මනට වයින් වෙලා යනවා. මෙන්න මේකට වැඩිය. right 60 Celsius තියෙන මේ setup එකේ purple color එක ඉක්මනටම colorless වෙනවා. then what is the conclusion? conclusion එක තමයි එතකොට මේකේ reaction එක rate එක වැඩි. ඉතින් ඉක්මනටම purple color decolorize. right? Then what's the conclusion? Conclusion is the rate of reaction increases with increasing the temperature. Right? Rate of reaction increases with increasing the temperature. That is the conclusion. This is a experiment we can use to demonstrate the temperature effect. Right? Then the most important thing, explanation. What's the explanation? That means why. The important thing is why the rate of reaction increase with increasing the temperature. That's the most important thing. That's the science. Right? So the temperature increase ka the reaction rate increase and the reason there are two reasons. First one, we know with increasing the temperature, kinetic energy of reactant molecule increase. Right? Kinetic energy of reactant molecule increases. Then what happen? Number of proper collisions, right? Number of proper collisions per unit time, per unit volume increases. තරුණාද? කරන තප්පරයකට කියලා අපි ගමු තප්පරයකට unit volume එක වෙන collisions ගන්න වැඩි වෙනවා. මොකද reactant molecule වල kinetic energy එක වැඩි වෙනවා. එතකොට reactant molecule මොකද වෙන්නේ? වේගෙන් එහෙම දුවනවා. හරිද? එතකොට මොකද වෙන්නේ? reactant molecule වල collisions වැඩි වෙලා collisions වැඩි වුණාම මොකද වෙන්නේ? proper collisions ගන්නත් වැඩි වෙනවා. right? collision වැඩි වුණාට ඇත්තටම වැඩක් නැහැ. proper collisions ගන්න තමයි increase වෙන්න ඕනේ. එතකොට අපි හිතමු නිකන් simply හිතන්නකෝ collision 1000ක් වෙනවා. 1000ක් වුණොත් proper collision අපි හිතමුකෝ 200 කියලා. දැන් මොකද එන්නේ collision 1000 කියන එක total collision ගාන 1000 එකෙන් 200 proper කියලා හිතන්න. එතකොට collision ගාන increase වුණොත් එහෙම 3000 වලට වගේ ගානකට. එතකොට 3000 collision වලින් proper collision සාමාන්‍යයෙන් 500 වගේ ඉන්න පුළුවන්. right? collisions ගාන increase වෙද්දී proper collisions ගානත් increase වෙනවා. Therefore, rate of reaction increases. Therefore, simply we can say the rate increases due to the increasing of number of proper collision. Then second one, right? Second one we can explain by using Maxwell-Boltzmann distribution curve, right? So here the kinetic energy and molecular fraction. Now consider this is the curve at T1. And consider we increase the temperature T2. और अभी गैस वेसन ने के स्टडी करना temperature increase करामा मैंने में curve के मैंने में हम वेनो हर the curve shifted to the right side, right? So now the activation energy here, right? Activation energy here, and this is T2 temperature. Now at T1, this amount of molecules have activation energy, right? Now at T2, what happened? Now this amount of reactant molecules have activation energy, right? तो temperature के වැඩි කරාම මොකද වෙන්නේ? reactant molecule energy එක වැඩි වෙනවානේ. तो energy එක වැඩි වුණාම මෙන්න මේ activation energy එක pass කරපු molecules ගාන වැඩි වෙනවා. එතකොට ඒ නිසාත් මොකද වෙන්නේ? reaction එක rate එක වැඩි වෙනවා. ඒ කියන්නේ අපි හිතන්නකෝ දැන් මේ වගේ දැන් A එකක් දෙන්නේ 75න්. එතකොට 75ට වැඩිය කියන්නේ නැත්නම් ළමයි ගන්න ලකුණු ගාන වැඩි වුණොත් මොකද වෙන්නේ? හරි ළමයි ගන්න ලකුණු ගාන වැඩි වුණොත් එහෙම නැත්නම් වැඩිපුර ළමයි ගානක් 75 පාස් කරොත් ඒතර ඒ ගාන වැඩි වෙනවනේ. අන්න ඒ වගේ reactant molecule වල kinetic energy එක වැඩි වුණාම මොකද වෙන්නේ? අර activation එක පාස් කරපු molecules ගානත් වැඩි වෙනවා. හරිද? ඒතර product එක හැදෙන්න නම් activation එක පාස් වෙන්න බෑ. ඒතර activation එක පාස් වෙච්ච molecule ගානත් වැඩි වෙන හින්දා reaction එක rate එක වැඩි වෙනවා. And keep in mind the activation energy. Activation energy එක තිබ්බ තැනම තමයි. ඒ energy barrier එකේ වෙනසක් වෙන්නේ නැහැ. temperature එක increase කරා කියලා energy barrier එක එතනම තමයි. හැබැයි අර reactant molecule වල kinetic energy එක increase වෙනවා. මේ energy barrier එක pass කරපු molecules ගන්න වැඩි වෙනවා. ඒතර ඔන්න reason දෙක හින්දා මොකද වෙන්නේ? reaction එක rate එක වැඩි වෙනවා. explanation එක තමයි ගොඩක් වෙලාට අපෙන් අහන්නේ. First thing, number of proper collisions වැඩි වෙන එකයි number of molecules having activation energy increase වෙන එකයි. ඒතර ඔය reason දෙක හින්දාම reaction එකේ rate එක increase වෙනවා. හරිද? අපි සාමාන්‍යයෙන් අනිත් factors ඊළඟ factors හතර consider කරොත් ඊළඟ factors හතරෙන් ඔය දෙකෙන් එකක් තමයි increase වෙන එක. ඒ කියන්නේ එක්ක proper collision increase වෙනවා. එහෙම නැත්නම් activation එක pass වෙච්ච collision ගන්න increase වෙනවා. ඔය දෙකෙන් එකක් තමයි වෙනස් වෙන්නේ. හරිද? તો temperature එක ස්පෙෂල් temperature එකේදී මොකද වෙන්නේ දෙකම වෙනස් වෙනවා හරිද දෙකම වැඩි වෙනවා එහෙනම් සාමාන්‍යයෙන් reaction එකේ rate එකට temperature එකේ effect එක ගොඩක් වැඩි හරිද right write down the topic temperature then write down under that to study the temperature effect for the rate of reaction to study the temperature effect for the rate of reaction to study the temperature effect for the rate of reaction following experimental setup can be used following experimental setup can be used draw හරි අඳින්න මේ setup එක write down the reaction as well the experimental setup and reaction Right. Then write down. Write down. It can be seen that. It can be seen that. It can be seen that the solution kept at higher temperature. It can be seen that the solution kept at higher temperature. Kept at higher temperature. Kept at higher temperature. Decolorize. 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 Kept at higher temperature, decolorize purple color, decolorize purple color faster, decolorize purple color faster than other solution. Decolorize purple color faster than other solution. Decolorize purple color faster than other solution. Other solution. Therefore, it can be concluded that, therefore, it can be concluded that, therefore, it can be concluded that the rate of reaction increases, the rate of reaction increases with increasing the temperature. Therefore, it can be concluded that the rate of reaction increases with increasing temperature. Rate of reaction increases with increasing temperature. Temperature. Right, then write down explanation. Write down the explanation. Write down explanation. First one, explanation number one. Number one. When temperature increase, when temperature increase, when temperature increase, when temperature increase, kinetic energy of reactant molecule increases. Kinetic energy of reactant molecule increases when temperature increase. Kinetic energy of reactant molecule increases. Kinetic energy of reactant molecule increases. Increases. Therefore, number of proper collisions, number of proper collisions, number of proper collisions, therefore number of proper collisions per unit time, per unit volume increases. Number of proper collisions per unit time, per unit volume increases. Number of proper collisions per unit time, per unit volume increases. Therefore, rate 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 increases. Then second one, second reason, second explanation. When temperature increase, when temperature increase, when the temperature increase, when the temperature increase, temperature increase, kinetic energy of reactant molecule increases. Kinetic energy of reactant molecules increases. Kinetic energy of reactant molecule 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 increases. Therefore, number of molecules, number of molecules, number of molecules having energy greater than activation energy. Therefore, number of molecules having energy greater than activation energy increases. Number of molecules having energy greater than activation energy increases. Number of molecules having energy greater than activation energy increases. Therefore, rate increases. Therefore, rate increases. Therefore, rate increases. Therefore, rate increases. It can be explained. It can be explained. It can be explained by using Maxwell-Boltzmann distribution curve. It can be explained by using Maxwell-Boltzmann distribution curve. Right. Draw this curve. Draw this curve. Draw this curve. Right. Then write down separately. With increasing the temperature, activation energy with increasing the temperature, activation energy does not change with increasing the temperature. Activation energy does not change. Activation energy does not change. Right. Then second factor is a concentration. Concentration. Right. To study the concentration factor, we can use this kind of experimental setup. This is water bath. Inside this water bath, we have to place two boiling tubes like this. And this water bath, water. Now here water at 25 Celsius. Here water at 25 Celsius. Here inside this boiling tube, we have to place two magnesium strip. I will draw using different color. This is a magnesium strip. We have to place two magnesium strip. Magnesium strip 2 centimeter length, right? And both are boiling tubes. Here in this boiling tube, this boiling tube contain 10 cubic centimeter water and 2 drops of HCl, and other boiling tube contain 10 cubic centimeter water and 4 drops of HCl. 4 drops of HCl, right? That means the concentration of HCl in this boiling tube is higher than this one. Then what's the reaction? The magnesium solid react with HCl, producing magnesium chloride aqueous and hydrogen gas. Then what's the observation? Observation means we can observe air bubbles are evolved, right? Air bubbles are evolved. So then we can observe the air bubbles evolve faster in this boiling tube. This boiling tube evolve more air bubbles than other one, right? So then what is the conclusion? This boiling tube evolve air bubble faster than this one. That means we can conclude that the rate of reaction in this boiling tube is higher than other one. Then what's the conclusion? The rate of reaction increases with increasing the concentration, because in this boiling tube the concentration of HCl is higher than this one, because to this boiling tube we had 2 drops of HCl, to this one we had 4 drops of HCl. Therefore the concentration of HCl is higher in this boiling tube, right? Then what's the explanation, right? Explanation means what's the concentration? N divided by V, right? So therefore what happened? With increasing the concentration, number of molecules per unit volume increase, right? Number of molecules per unit volume increase. Then what happened? Number of proper collision per unit volume increase. So the unit volume එක තියෙන molecules ගාන වැඩි වෙද්දි මොකද වෙන්නේ? Collisions ගාන වැඩි වෙලා proper collisions ගාන වැඩි වෙනවා. Therefore rate of reaction increases, right? And with increasing the temperature, keep in mind Number of molecules having activation energy does not change. Activation එක pass කරපු molecules ගාන වෙනස් වෙන්නේ නැහැ. And activation energy energy barrier එකට value එකක් තියෙනවා. ඒ value එක වෙනස් වෙන්නේත් නැහැ. හරිද? Otherwise we can say like this. I told you here this in region B there are two type of molecule. What is the one type? This one. Molecules collide improperly having activation energy. එතකොට මෙන්න මෙතන තියෙනවා මේගොල්ලන්ට activation එක තියෙනවා මේ ඔක්කොටම. හැබැයි මෙතන තියෙනවා මොකද්ද? properly collide වෙන්න බැරි ටිකක් තියෙනවා. ඒතර concentration එක වැඩි වුණාම මොකද වෙන්නේ? මෙන්න මේගොල්ලොන්ට properly collide වෙන්න chance එකක් හම්බ වෙනවා අර unit volume එක තියෙන molecules ගාන වැඩි හින්දා. ඒතර ඒගොල්ලොමුත් මොකද වෙන්නේ? product එක හදනවා කියන්නේ අපේ unit volume එකදී හම්බ වෙන product amount එක increase වෙනවා. right? එතකොට activation එක pass කරපු molecule ගාන increase වෙන්නේ නැහැ. මොකද molecule වල energy එකට මොකුත් වෙනසක් වෙන්නේ නැහැ. ඊට පස්සේ activation එක තිබ්බ තැන එහාට මෙහාට වෙන්නේ නැහැ. ඒක හැමම තමයි. ඒ නිසා අර activation එක pass කරපු මෙන්න මේ area එකේ මොකුත් වෙනසක් වෙන්නේ නැහැ. concentration වැඩි කරත් මේ curve එක මෙහෙමම තමයි එන්නේ. හරිද? Therefore, with increasing the temperature, simply we can say the rate increases due to the increasing of number of proper collision. Right. Write down concentration, the factor, then write down under that to study the concentration effect. To study the concentration effect, following experimental setup. To study the concentration effect, following experimental setup can be used. Following experimental setup can be used. Draw the setup. Right, then write down, it can be seen that, it can be seen that the boiling tube, it can be seen that the boiling tube containing, it can be seen that the boiling tube containing 4 drops of HCl, it can be seen that the boiling tube containing 4 drops of HCl, containing 4 drops of HCl, 4 drops of HCl evolve, 4 drops of HCl evolve, boiling tube containing 4 drops of HCl evolve gas bubbles, evolve gas bubbles faster than other one, evolve gas bubbles faster than other one, evolve gas bubbles faster than other one. Therefore, it can be concluded that, 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 it can be concluded that the rate of reaction increases, it can be concluded that the rate of reaction increases, the rate of reaction increases, the rate of reaction increases with increase in the concentration of reactant. The rate of reaction increases with increasing the rate of reaction increases with increasing the concentration of reactant, with increasing the concentration of reactant, with increasing the concentration of reactant. Right. Then write down the explanation. Write down explanation. Write down as explanation. Explanation. Then write down under that, when concentration increase, when the concentration increase, when the concentration increase, when the concentration increased, number of molecules, number of molecules, number of molecules, number of molecules per unit volume increases, number of molecules per unit volume increases, number of molecules per unit volume increases, number of molecules per unit volume increases. Therefore, number of proper collisions, therefore, number of proper collisions, therefore, number of proper collisions per unit volume, number of proper collisions per unit volume per unit time increases, number of proper collisions per unit volume per unit time increases, number of proper collisions per unit volume per unit time increases, per unit volume per unit time increases. Therefore, the rate increases. Therefore, the rate increases. Therefore, the rate increases. Therefore, the rate increases. Then write down separately. With increasing the concentration of reactant, 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 activation energy or 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 number of molecules, activation energy or number of molecules, number of molecules having energy greater than activation energy, number of molecules having energy greater than activation energy, number of molecules having energy greater than activation energy, energy greater than activation energy, do not change, don't change, do not change, do not change. Right. Then third factor, and here there's another small thing, keep in mind. The rate of reaction independent of the concentration of products, right? The rate of reaction depends on the concentration of reactant. Write down that sentence. The rate of reaction independent of the rate of reaction, the rate of reaction is independent of the concentration of product. The rate of reaction independent of the concentration of products. The rate of reaction is independent of the concentration of product. Concentration of product. Right, then third factor, surface area of solid reactor. Surface area of solid reactants. Right. To study the surface area, we can use this kind of experiment setup: water bath, boiling tube, and here there is a water at 25 Celsius, water at 25 Celsius, and here for one boiling tube, we have to add calcium carbonate lump and other one calcium carbonate dust. So here m gram is a mass, m gram of calcium carbonate lump, another one m gram of calcium carbonate powder dust. And for both boiling tube, we have to add both boiling tube, we have to add 0.001 moles per decimeter, 10 cubic centimeter HCl for both boiling tube. Then what's the reaction? The calcium carbonate solid react with HCl, forming calcium chloride, carbon dioxide gas, and water. So then we can observe evolution of carbon dioxide gas, right? And it can be observed that the boiling tube containing calcium carbonate powder evolve more carbon dioxide gas than other one, right? This evolve more carbon dioxide than this one. Then what's the conclusion? Conclusion is the rate of reaction increases with increasing surface area of solid reactant. That's the conclusion. Then what's the explanation? With increasing the surface area, number of propagations per unit time per unit area. Now there is a solid, therefore per unit time per unit area, number of propagation, number of propagation increases, right? Therefore rate increases. And here same thing, with increasing the surface area of solid reactant, activation energy or number of molecules having activation energy do not change, right? That's all. Okay, write down third factor, then surface area of solid reactant. Surface area of solid reactant is a third factor. Then write down under that, to study the effect of surface area, to study the effect of surface area, following experimental setup can be used. Following experimental setup can be used. Draw the setup. Right, then write down it can be observed that it can be observed that it can be observed that the boiling tube containing calcium carbonate powder, it can be observed that the boiling tube containing calcium carbonate powder, the boiling tube containing calcium carbonate powder, the boiling tube containing calcium carbonate powder, the boiling tube containing calcium carbonate powder evolve, the boiling tube containing calcium carbonate powder evolve carbon dioxide, evolve carbon dioxide, the boiling tube containing calcium carbonate powder evolve carbon dioxide faster than other one. The boiling tube containing calcium carbonate powder evolve carbon dioxide other faster than other one. Therefore, it can be concluded that therefore it can be concluded that therefore it can be concluded that the rate of reaction increases. It can be concluded that the rate of reaction increases. The rate of reaction increases with increasing the rate of reaction increases with increasing the it can be concluded that the rate of reaction increases with increasing the surface area of solid reactant with increasing the surface area of solid reactant with increasing the surface area of solid reactant. Then write down explanation. Write down the explanation. When surface area increase, when the 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 surface area increase, number of proper collisions when the surface area increase, number of proper collisions per unit time, per unit volume, per unit time, per unit area, per unit time, per unit area increases, number of proper collisions per unit time, per unit area increases, per unit time, per unit area increases. Therefore, rate increases. Therefore, the rate increases. Therefore, the rate increases. Therefore, the rate increases. Therefore, the rate increases. Then next write down with increasing the surface area, 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 activation energy O, activation energy O, activation energy O, with increasing surface area, activation energy O, number of molecules having activation energy, number of molecules having activation energy, number of molecules having activation energy do not change. Number of molecules having activation energy don't change, don't change. Right, then fourth one, catalyst. Fourth one, catalyst. Right. So what is the definition of catalyst? The definition is the substance that can be used to increase the rate of reaction known as catalyst. The substance that can be used to increase the rate of reaction known as catalyst. Right. So to study the effect of catalyst, we can use this kind of experimental setup. So here there are two boiling tube and we have to use water bath. In each experiment, why we use the water bath? The water bath is used to maintain the constant temperature, right? The rate of reaction depends on the 5 factors. Therefore, when we study some factor, the other factor should be constant, right? When you study the catalyst, temperature, concentration, surface area, those things should be constant. That is why to maintain the constant temperature, we have to use water bath, right? Water bath at 25 Celsius. Therefore, both boiling tube present in same temperature. And here, what we have to add for each boiling tube, we have to add hydrogen peroxide, 10 cubic centimeter hydrogen peroxide, 10 cubic centimeter hydrogen peroxide. And for this boiling tube, we have to add 5 cubic centimeter water other than hydrogen peroxide. Another boiling tube, we have to add 5 cubic centimeter of 0.1 moles per decimeter sodium hydroxide. Both boiling tube, 10 cubic centimeter hydrogen peroxide should be added. And for one boiling tube, 5 cubic centimeter water, and other boiling tube, 5 cubic centimeter sodium hydroxide should be added. Then what is the reaction? The hydrogen peroxide decompose, producing water and oxygen. I think this is given in the P block, right? Due to the formation of oxygen, we can observe that air bubbles evolve, right? So then what is observation? We can observe that the boiling tube containing sodium hydroxide, the boiling tube containing sodium hydroxide evolve air bubbles much faster than other one. This boiling tube evolve air bubbles much faster than other one. Then what is the conclusion? What is only the difference? What is only the difference between this boiling tube? Same temperature, same concentration, because 10 cubic centimeter of same H2O2 solution should be added to the both. Concentration same, temperature same. This contain NaOH, this does not contain NaOH, right? Then this is only the difference. Sodium hydroxide is added to this one. Then we can observe the rate of reaction is higher in this one. Then what is the conclusion? The sodium hydroxide act as catalyst in this reaction. That's the conclusion. Sodium hydroxide act as catalyst, and the catalyst increase the rate of reaction, right? So then explanation, right? So the catalyst explanation is this one. Catalyst, right? The potential energy and reaction coordinate, right? When the catalyst is added, what happen? When catalyst is added, the reaction way, right, we known as a mechanism. Can catalyst එක add කරාම reaction එක වෙන method එකක් තියෙනවා. ඒකට අපි mechanism කියලා කියන්නේ. ඒකත් පස්සේ discuss කරනවා. එතකොට catalyst එක reaction වෙන mechanism එක සම්පූර්ණයෙන් වෙනස් කරනවා. එයා reaction එක කරනවා අලුත්ම ක්‍රමයකට. අපි සාමාන්‍යයෙන් කියන්නේ the catalyst like a teacher. catalyst කියන්නේ නිකන් teacher කෙනෙක් වගේ. හරිද? දැන් ඔයගොල්ලෝ තනියම study කරලා අපි හිතමු chemistry තනියම study කරලා මොකක් හරි දෙයක් කරනවා. එතකොට ඔයගොල්ලෝ තනියම ස්ටඩි කරලා මොනවා හරි යුනිට් එකක් තේරුම් ගන්න සෑහෙන ඔයගොල්ලෝ ඉෆෙක්ට් එකක් දාන්න ඕනේ. සමහරවිට බෑ. නැත්තම් සෑහෙන ඉෆෙක්ට් එකක් දාලා තමයි ඒක කරන්න වෙන්නේ. හරි අමාරුයි. තේරුණාද? එතකොට ටීචර් කෙනෙක් මොකද්ද කරන්නේ? ටීචර් කෙනෙක් ඒක ස්ටඩි කරන්න ලේසි මෙතඩ් එකක් කියලා දීලා ඒක තේරුම් කරලා අර කලින්ට වඩා වෙන ඔයගොල්ලෝ කලින් අර තනියම self study කරලා ඔයගොල්ලෝ ස්ටඩි කරනවට වඩා වෙන ක්‍රමයකට තමයි උගන්වන්නේ. එතකොට ඒ උගන්වන ක්‍රමෙන් ඕගොල්ලන්ට ඒක අල්ලා ගන්න මොකද වෙන්නේ? ලේසි. එතකොට ඕගොල්ලන් ටීචර් කෙනෙක් ගාවට යන්නේ ඒකයි. තේරුණාද? ඒතර ඒ වගේ කැටලිස්ට් එක ඇඩ් කරාම කැටලිස්ට් එකේ රියැක්ෂන් එක වෙන ක්‍රමේ සම්පූර්ණයෙන්ම වෙනස් කරනවා. ඔහොම නෙවෙයි රියැක්ෂන් එක මෙයා වෙන පාරක් කියලා දෙනවා. ඔහොම නැතුව මේ පාර යන්න කියලා වෙන පාරක් කියලා දෙනවා. එතකොට ඒ කියලා දෙන අලුත් පාරේ අලුත් පාත් වේ එකේ මොකද වෙන්නේ? ඇක්ටිවේෂන් එනර්ජි එක අර කලින් පාරට වැඩිය අඩුයි. ඕගොල්ලන් තනියම ස්ටඩි කරලා මොනවා රිසල්ට් එකක් ගන්න දෙන්න ඕන මහන්සිය ගොඩක් වැඩි. හැබැයි ටීචර් කෙනෙක් ඇවිල්ලා ඔයගොල්ලන්ට ඒක ඊට වඩා ලේසි ක්‍රමයකින් ඊට වඩා අඩු එනර්ජි එකකින් අඩු ඉෆෙක්ට් එකකින් කරන්න ඕනේ අලුත් මෙතඩ් එකක් තමයි කියලා දෙන්නේ. හරිද? තුරන් ඒ වගේ we can draw like this. Now think this is a reaction without activation energy. This is reactant and this is product. This is activated complex and this is the activation energy. මේක තමයි activation energy එක. This is without catalyst. මේ catalyst එක නැති වෙලාවේ. හරිද? Without catalyst. When catalyst is added, what happen? It we can say it provide alternative pathway, right? That means it provide new pathway like this. It provide new pathway like this. What is the important feature of this pathway? The activation energy of this new pathway is lower than without catalyst. This is with catalyst. So the activation energy with catalyst, we can say activation energy with catalyst is this one, green color one, and activation energy without catalyst this one. So we can observe the activation energy with catalyst is lower than other one, right? Therefore, what happened? We can understand by using Maxwell-Boltzmann molecular fraction kinetic energy. When catalyst is added, nothing happened to the shape of this Maxwell-Boltzmann distribution curve, but now here think this is activation energy without catalyst. Without catalyst. So therefore, molecule present in this region have activation energy. When catalyst is added, now it provide alternative pathway, then the activation energy of that pathway is lower than previous one. Then what happened? Now we can observe the area, that means the number of molecules having energy greater than activation energy now increase. So activation එක pass වෙච්ච molecules ගාන වැඩි වෙනද reaction එක rate එක වැඩි වෙනවා. හරියට නිකන් මේ වගේ අපි හිතමු දැන් A එක දෙන්නේ 75නේ. බැරි වෙලා හරි ඔය ඒක දෙන margin එක 70 කරොත් මොකද වෙන්නේ? ඒතකොට ඒ ගාන වැඩි වෙනවනේ. හරි? අන්න ඒ වගේ මේ energy barrier එක මොකද කරන්නේ? activation energy එක අලුත් පාරක් හදලා ඊට වඩා අඩු energy barrier එකක් තියෙන පාරක් හදලා දෙනවා reaction එකට. එතකොට මොකක්ද වෙන්නේ? ඒ energy barrier එක pass වෙච්ච molecules ගාන වැඩි හින්දා එතකොට වැඩිපුර product එකක් අපිට හැදෙනවා. right? එතකොට මෙතනත් especially මතක තියාගන්න when catalyst is added number of proper collision does not change. proper collision ගාන මොකුත් වෙන්නේ නැහැ. කලින් තිබ්බ proper collision ගානම තමයි දැන් තියෙන්නේ. හරිද? හැබැයි මෙන්න මෙහෙම අපිට කියන්න පුළුවන් මෙන්න මෙතන මම කිව්වා මෙන්න මෙතන සෙට් එකක් ඉන්නවා මේගොල්ලොන්ට ප්‍රොඩක්ට් එක හදන්න බෑ. මේ පැති දෙන්නෙක් ඉන්නවා කිව්වනේ. properly collide වෙනවා. හැබැයි activation එක නැහැ. දැන් මේගොල්ලොන්ට මොකද වෙන්නේ? අර activation barrier එක අඩු වුණානේ. හරි? මේක පිටිපස්සට ආවෙන්න මෙන්න මේ පැත්තේ properly collide වෙන කට්ටියට මොකද වෙන්නේ? ප්‍රොඩක්ට් එක හදන්න දැන් chance එකක් තියෙනවා. අර 70යි 75යි ලකුණු ගත්ත කට්ටියටත් දැන් ඒකක් ගන්න පුළුවන්. මොකද ඒක ගන්න ඒකේ මාජින් එක 70ට අඩු කරපේන්න. හරිද? අන්න ඒ වගේ දෙයක් තමයි මෙතන වෙන්නේ. right. write down to study the effect of catalyst. To study the effect of catalyst, following experimental setup. To study the effect of catalyst, following experimental setup can be used. Draw. Draw. Right, then write down it can be observed that it can be observed that it can be observed that the boiling tube containing sodium hydroxide, it can be observed that the boiling tube containing sodium hydroxide, the boiling tube containing sodium hydroxide, the boiling tube containing sodium hydroxide evolve gas bubbles, evolve gas bubble faster than, evolve gas bubble faster than, evolve gas bubbles faster than other one, evolve gas bubble faster than other one, evolve gas bubbles faster than other one, faster than other one. Therefore, 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 it can be concluded that, therefore, it can be concluded that, therefore, it can be concluded that the sodium hydroxide act as a catalyst. It can be concluded that the sodium hydroxide act as a catalyst. The sodium hydroxide act as a catalyst and the sodium hydroxide act as a catalyst and sodium hydroxide act as a catalyst and it increases the rate of reaction. 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 Right, then write down explanation. Write down explanation. Write down explanation. Write down explanation. The catalyst provide alternative pathway. 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 Catalyst provide alternative pathway having lower activation energy. 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 Therefore, number of molecules having, therefore, number of molecules having, number of molecules having energy greater than activation energy increases. Therefore, number of molecules having energy greater than activation energy increases. Number of molecules having energy greater than activation energy increases. Number of molecules having energy greater than activation energy increases. Therefore, rate increases. Therefore, the rate increases. Therefore, the rate increases. Then I done a separate sentence. When catalyst is added, when catalyst is added, when catalyst is added, when catalyst is added, number of proper collisions do not change. When catalyst is added, number of proper collision do not change. Number of proper collisions don't change. Right, draw quickly. Draw. Right. So then I will stop the class. So next week I will continue the theory of this topic, and next week we can start to practice equation, right? And this board I will send as a PDF in the WhatsApp. So if you miss something, you can write down, right? So then come to the next class. Good night all.